Hey, welcome back to your favorite technical mathematics class. We're going to take a look at similar triangles today. So similar triangles just mean if you have two triangles of different sizes, in other words, the side lengths, and they don't have to be different sizes, they can be the same size. But what's going to happen is if you have, let's say this one, A, B, and C, if these A prime, B prime, and C prime, if A, B, C is truly similar to A prime, B prime, C prime, then this angle will be the same as this angle. So if that's 30 degrees, that one will be 30 degrees. If this is, I don't know, 100 degrees, B, then B prime will also be 100 degrees, which leaves you with 50 degrees for C and C prime. Okay? So if you're looking at these, find the measure of the missing angles. Notice, and you know what, let me blow this up a little bit. You've got this N is 25 degrees right there, and the K is 106 degrees. So notice NMK, so it goes with the 1, 2, and then M is the remaining one, would go with, so NMK, or I should say, let me do it in order, MNK would be similar to, so blank to the 1 slash to the 2 slashes would be blank, here's the blank A, so M goes with A, and then to the 1 slash C, so there's the 1 slash C, and then the 2 slashes with the B. Okay, so if N is 25, then C is 25. You can see that. N is 25, C is 25. If K is 106, the 2 slashes. If K is 106, B is, angle B is 106. And remember, all three angles in a triangle add up to 180 degrees. So, 106 plus 25, you've got 131. So the remaining side length would be 49. So that's got to be 49 degrees right there, M, which means this A right here would have to be 49 degrees. So angle A, 49 degrees. Assume that ABC is similar to triangle A prime, B prime, C prime. So A, B, C, A, B, C, A prime, B prime, C prime. So if AB is 13, BC is 14, so now these are side lengths, and AC is 16, and the shortest side of A prime, B prime, C prime is 18, so the shortest side. Well, the shortest side of the triangle here is the smaller triangle is 13. So that means that the shortest side would be A prime, B prime, the correlating side. So that's 18. So find the other two sides. Well, they're obviously not the same side lengths because they're different sized triangles, but now you can set up a ratio. So 13 is to its corresponding side 18. So 13 is to 18 as, and let's do the 14 is to, let me call it X right here. So X is B prime, C prime. 14 is to X. And then we could just cross multiply. So this becomes 13 times X is 13X. And then you've got 18 times 14, which ends up being 252. Divide both sides by 13. And you've got X is 19.385. I'm going to round that to 4, 19.4. Okay, so this is 19.385, 19.4. Okay, now let's do the same thing. So let's go 13 is to 18. That's the ratio. 13 is to 18 as 16 is to, let's call this y right there. This 16 is to y, and again, we cross multiply. So 13y, 16 times 18 gives us 288. Divide by 13 on both sides, and you get 22.154. So 22.2. Whoops, that was, I should call this A prime C prime as 22.2, not Y. And this X, I should call B prime C prime as 19.4. Okay, not the X. Alright, so let's do this this last example here. On level ground, an oak tree casts a shadow 36 meters long. At the same time, a pole 9 meters high casts a shadow 12 meters long. How high is the tree? Let me erase this real quick. Get a little room. Alright, so let's see if we can draw this. We've got level ground. We've got sun up here. We've got this oak tree. And the sun's casting its ray like that. So the oak tree casts a 36 meter long shadow right here. Okay. So there's the oak tree shadow on the ground. And then you got this pole at the same time. Here's your pole, and it's casting a shadow right here, 12 meters long itself. So you got two triangles in there. You got this smaller one with a 12 meter, and by the way, this pole is 9 meters tall. 9 meters tall. You've got the oak tree. We don't know. We're trying to figure out how high is the tree. So let's call it X. How high is that tree? It's casting a 36 meter shadow. Okay. Well, these are both right triangles, so these are similar triangles. So I'm going to go 9 is to X. 9 is to X as 12 is to 36. 12 is to 36. So this becomes 9 is to X. I'm going to go ahead and simplify. 12 over 36 is 1/3. You know, 12 divided by 12 is 1. 36 divided by 12 is 3. And then I'm going to go ahead and cross multiply. So 9 times 3, 27 equals 1 times X is X. So it looks like that tree's 27 meters tall. Well, thanks for watching. You can use those similar triangle properties today. We'll see you soon.